In the second question, we're asked to show that if the given functions can be autocorrelation functions R or power spectrum S of omega. And so we're given three different functions. We have to take a look at all three of them. For a function to be an autocorrelation function of a real wide-sense stationary stochastic process, it should be an even function, and it should have a peak value at 0. And its Fourier transform should be non-negative because it's a real system, and then the power spectrum must be non-negative. Yeah, and secondly, the power spectrum has to be non-negative. So let's take a look at the first function given here. F of v is e to the power of minus absolute value of v. So firstly, we know that this function is an even function because there is an absolute sign. And secondly, the function has the largest value at f0. Thirdly, we know that e to the power of something minus absolute value of v correlates or corresponds to this 2 alpha divided by alpha squared and plus omega squared. This is derived by the transfer table. We know that this would be the form of the power spectrum after the Fourier transform, and this is also non-negative. And so that we know the first function is can be an autocorrelation function. And because the first function is always no less than 0, we know that it can be a power spectrum. The second function is sine of v squared divided by v squared. We know that it is even. And we know that the value has a peak at 0, and that would be 1. And all other times it would be no larger than 1. And this function corresponds to this power spectrum after the Fourier transform, which is a non-negative function. So function b can also be a autocorrelation function. And secondly, this function is also no less than 0. Therefore, it can also be a power spectrum. And thirdly, we have a gate function. When v is between minus alpha to alpha, the value is 1, otherwise it's 0. So if we do a Fourier transform of this gate function, we have a result something like this. It would be a sinc function, which is not non-negative, so it cannot be an autocorrelation function. But because f of v is always no less than 0, is always non-negative, so function c can actually be a power spectrum.